In this next video, we're going to continue on with the components of a hypothesis test for one proportion. In the previous video, we looked at the first two components, which are to, first off, state your null and alternative hypotheses, and then second, check the central limit theorem. Reminder, hypothesis testing is just another type of statistical inference. And that's when we use a sample and its statistic to make an assertion about the population and its parameter. After those first two steps are done, you want to find some values from your sample. You want to find your z-score, your p-value, and your sample proportion. The p-value is the one that we're really going to focus in on, especially in the next step. To find these, we're going to use your calculator. First off, you'll hit the stat button. You'll go over to tests like we did in chapter 7 for the confidence interval. And you'll scroll down to number 5, one prop z-test. You select that. PO is your population proportion, the value from HO. What did you set P equal to? X is the number of successes, and that's the actual number of successes, not the expected number, but the actual number of successes from your sample. N is the sample size, and you select your prop symbol based off of the symbol in your alternative. Did you use not equal to? Did you use less than or greater than? And then you select calculate, and you'll get these values, your z-score, your p-value, and your sample proportion, or your p-hat. Once you have those, you're ready to make a decision about your hypotheses. You have an HO and you have an HA, and you have to decide, are you going to keep that original baseline idea from HO, or are you going to reject it and go with the alternative? In order to make that decision, you use your p-value. If you read the problem carefully, you'll see that you have a level of significance, or a significance level, and that's the Greek letter alpha. So if your p-value from your calculator is less than this given alpha, then we have enough evidence to reject the idea of HO. We would say we reject HO and its idea, and the data are statistically significant to conclude the idea of the alternative of HA. On the other hand, if the p-value is greater than alpha, we say that we do not reject HO, or we fail to reject HO. That's the wording we use. We don't have enough evidence to throw out HO. Therefore, the data are not statistically significant to conclude the idea of HA. Essentially, we're adding in the words not when the p-value is greater than alpha. This is something you definitely need to know, that you definitely need to be familiar with for this class. To me, this is one of the most important things to know, and I expect you to be very familiar with this information regarding a p-value and whether it's less than or greater than alpha. Before we move into our coin spinning example, let me talk about the significance level just a bit more. The significance level which will be given to you, that's your alpha, which you use to compare your p-value. This is the probability of rejecting the null hypothesis when the null hypothesis is actually true. It's the probability of making a mistake. Remember that we're never 100% certain in statistics. There's always room for error. There's always a chance that we're off because we're just using a sample to make an assertion about the population. So something crazy, something funky might happen in that sample, which is not at all like the population, and that leads us to the wrong conclusion. So we always need to keep that in mind, that we've never proved anything, that we're never exact, we're never 100% sure, but this is what the statistics are showing, but there's a small chance for error. To get back to our coin flipping example that we saw in the previous video, once again, We know that flipping a coin high into the air yields equal probabilities for heads and tails, 50% chance for heads, 50% chance for tails. But we're looking at spinning the coin, making tails more likely, because the head side protrudes a little bit more than the tail side. Our sample is a coin that's spun 100 times, and it comes up tails 64 times. We want to know, can we conclude tails is more likely at the 5% significance level? From the previous video, HO was P equals 0.50. HA was P is greater than 0.50. We checked the components of the central limit theorem and found they were met. And so what this tells me is that I'm dealing with a normal distribution, and I expect my P to be in the middle. So 0.50 is right here. If I continue on with the third step to find my z-score, my p-value, and my p-hat, my sample proportion, I would go to my calculator. Once again, this is stat tests number 5, the one prop z-test. PO is going to be 0.50. That's the value from HO. X is my number of successes from the sample, so that would be 64. N is not the failure number, N is the sample size, N is 100. And this symbol is selected from my alternative. HA was a greater than, so I'll scroll over. It's not enough to just hover over this symbol. Not equal to is still selected. I just hit enter to select it, and then I can go to calculate. And there are the 3 values that I need. My z-score is 2.8. My p-value is 0.0026, if I round that to 4 places. And my sample proportion p-hat is 0.64. This information goes back to the normal curve. P-hat of 0.64 tells me that I'm way up here with my sample. This has a z-score of 2.8. So it's so far above the mean of 0.50 in the middle that it is an outlier. There's my p-hat, it's 0.64, it has a z-score of 2.8. This p-value, this is the probability in the tail. The p-value is defined to be the probability of observing a sample as extreme or more extreme given the conditions of your hypothesis test. So what this is telling me is there's only a 0.0026 chance that I could observe a sample of 64% if the population is actually 50%. There's a very, very slim chance. And what this goes back to is that fourth and final step. I'm going to use this p-value. And I'm going to compare it to my significance level, my alpha, 5%. The p-value in this case is less than alpha. The p-value of 0.0026 is less than 0.05. 5% is the same as 0.05. 0.002 is less than 0.05. So because of this, because the p-value is less than alpha from the table above, I reject HO. I'm throwing out this idea. I don't think that spinning a coin is going to give me 50-50 odds for heads and tails. Instead, I think it is actually going to be greater than 50% for tails. So I could say that the data that we have collected from this sample, the data are statistically significant to conclude tails is more likely than 0.50. I don't know exactly what it is, but the evidence that I have is saying that it's somewhere greater than 0.50. It may not be exactly 0.64, it may be 0.60, it may be 0.58, but I'm fairly certain that when you spin a coin on a table, tails is going to show up more than 50% of the time based off of this study. We're going to look at some more examples in the next couple of videos to get a better idea of these 4 steps all at once.